Amongst the numerous mysteries of the universe, a particularly big one is how galaxies are formed. We estimate the very first galaxies began forming 100 million years after the Big Bang, or over 14 billion years ago. That's ancient history, so you can understand why it might be difficult to study such a thing. To put it another way, it's something like if you were to observe me now and then you were trying to deduce what happened to me when I was a couple months old that led me to pursue a PhD thesis in physics and talk with you right now with this ridiculously long hair. So we need to model this. And in physics, we like to have simple models. Ours is this. Small things group up and form bigger things. So atoms form gases, gases form stars, and stars form galaxies. So we take this model, and with the help of high-resolution computer simulations, we can make some progress. To continue the analogy from before, it's like we found some pictures of a baby right after birth, and we used the understanding of human development to deduce what the baby might have looked like 3 months later. Similarly, we take telescopic observations of the early and present universe, and we take that model, small going to big, and we try to fill in the gaps and to paint a big picture of the whole thing. This works really, really well. This plot was taken from a simulation that we ran. We can now produce simulated galaxies that are statistically identical to real galaxies. But there's something missing here in this picture that probably isn't obvious to you at all. That's magnetic fields. Observations show us that magnetic fields are everywhere in the universe. Even around the Earth, there's a magnetic field that shields us from cosmic rays. So what I've done for my thesis is to create a model to introduce magnetic fields into our simulations. Just in keeping with our theme, we take small magnetic fields, and then they will later evolve to be bigger magnetic fields. So you might be wondering at this time, why should we even care about magnetic fields? Well, we believe that magnetic fields play a central role in controlling how frequently and where stars are formed. Just as the human body has systems that regulate the chemical balances, like insulin for sugar, we believe that magnetic fields regulate star formation. As you can see from our plot, much of what you guys all recognize as a galaxy is based on how the stars are distributed. Therefore, if we know where the stars are forming and how they form, we can predict exactly how galaxies are formed. We believe that magnetic fields may be the missing piece to completing the puzzle of galaxy formation. Thank you.